Alright, so for this data set here, we are going to retrieve historical team and player stats using the Pro Football Reference website. So there are several websites or several links we are going to use to get to our final data set, and I'm going to take you through that process here. So beginning off, as always, we are going to import our packages and libraries, and I believe this is the first time we will see this library or this package here, Beautiful Soup comment. And the reason for this is because on the if I could get to it here, on the Pro Football Reference page, for some reason, all of these values are hidden behind a comment. Even though I can inspect and go to that exact element, just like I would on any other website, for some reason when I try to do that same method here, it doesn't work. And I noticed that on this website, the values were actually hidden under a comment. So you can see here we have the attribute and then the attribute value, and then we have the text here, we have our tag, so on and so forth. When I try and search for scope, row, or class left, or even data stat, I'm not retrieving any text here. Like this would be opponent stats. When I search for it, for some reason it doesn't work. So somewhere along this HTML code, they have a huge comment block where they hold all of these data values. So this is why we are going to use that new package there. Other than that, everything else we've seen before, and we can quickly move on to the coding section. So this block of coding here isn't really necessary, nor is this one here. When I code, I usually like to try different things out, and I forgot to delete these two blocks of coding, and they really do not serve a purpose other than just setting up the variables that are there already. But these are basically two of the same things, just one is slightly different. So we could ignore this one, and I'll probably remove this one in the future or even after this video has been recorded. But we could pay attention to this block of code in here, team stats and rankings. So the link we are going to use is this profootballreference.com/teams. And the first thing we need to do, and the first thing I should explain my thought process into getting all of the team and player stats from 2010 all the way up to our current year, is that we have to go through a couple of steps. The first thing we have to do is actually get a link to all of the team pages. So the good thing about the Pro Football Reference website, and the reason why I chose them, is because they have a whole bunch of information that is very useful and is exactly what I'm looking for. So the first thing we needed to do was to grab a list of all the teams. And on the Pro Football Reference website, we have here, if you come to this link, we have current and non-current teams. And if you have a current team, or if a team is current, they have a underline under their names. And if you click on it, if you click on the current team name, it'll take you to that team page. So this is exactly what we need, because when we go to inspect this current team name and we're looking at the Arizona Cardinals here, we are able to then dig down deeper to get a team link that'll take us to that page that we see previously. So once that loads up, you can see that there's a link behind it. So we have our A tag and we have our attribute variable of href, and we have our value here. This link is not the complete link, so we have to set up a bit of a placeholder link, but that is something that we can do very easily. So this is the value we want to return. So let's go back to the code in here. We are going to use this website go through all the regular steps of opening the web page and closing the web page and doing all that good stuff. And then I set up a variable called pp, but you are going to see this later on in the loop here. So we have it where we are looking for the team name, and after that, once we do that, and this is, we could just immediately hop into the loop here. This is basically the same information. So once we go through all of those steps, we then are going to create a loop, and we create a couple more things. W is equal to 0, and link staging is just a empty list. So now moving on to our loop here, we have W less than 100. If W is less than 100, we are going to create the variable pp. We're looking for the team name, of course, and we do that multiple times before we even get to the loop. And then we are going to try and find the a tag with the attribute of href, and it's going to return the ending part of that link, or the ending part for the specific team we are currently looking at. And we are going to look at W, the position of W, whichever it is. So the Arizona Cardinals, and if we go back, just have an ad blocking it. The Arizona Cardinals, starting from W where it's equal to 0, is going to be the first team up. Number 1 is going to be the Atlanta Falcons, and it's going to retrieve whichever ending part here for the H reference, or the link. So now, once that is completed and we have the href value, we are then going to append it to our empty list on the outside of the loop. And you can see before we do that, we are going to combine it with a placeholder link with the href value, we add 1 to W, and we continue on until we hit 100. So once we hit 100, we are going to break the loop. So now we have all of our teams and their website page. So you can see here, this is the Arizona Cardinals. They are going to end in CRD, and then the Atlanta Falcons ATL. Just know that we have the link, and this is the page that we seen earlier. So it's taken us to this team page, but we're not done yet, because we need more information, or we need specific information for that specific team in a given year, anywhere from 2010 all the way up to 2020 or even 2021. So now we move on to the next block of coding. So we have all of our teams and their website pages. Moving on to the next block of coding, we have new variables to introduce. Years is equal to 2010, N is equal to 0, Q is equal to 0 as well, and team years is equal to a empty list. So now, before I explain what the loop is going to do, we have to grab the specific team year so we can retrieve the stats for that team. And if you look, this is the Arizona Cardinals in 2010. You can see they finished 5-11, but this is not the information we really need. The information we're looking for is this table here: team stats and rankings, and team conversions, passing, rushing and receiving, kick and punch return, kicking and punting, defense and fumbles, and that'll be it. And we're gonna scrape that information later on. So while years is less than or equal to 2021, we are going to perform these steps. Years is going to get converted to a string, and the reason for this is because we cannot combine integer with a string already. And then we set up a new variable called CR, and it's basically going to look at the position whichever specific number n is on is going to look at it in our list. So the Arizona Cardinals is up first if we were starting from 0, and it's going to add this years variable, which is already converted as a string, and then it's going to add .htm, and that's how we get our specific team for a specific year and their data. So since 2010 was already loaded, we can take a look at 2011. And you can see we have the 2011 Arizona Cardinals statistics and players. And then we are going to append it to our empty team years list on the outside of the loop. And then if Q is equal to 11, we're going to add n. We're going to add 1 to n and reset Q back to 0. And then we are going to set the years variable back to 2010 as well. Q is just basically representing the number of years, so 2011 to 2020, once that hits 11, we're going to reset it, and then you can see that the years is reset back to 2010. And then if n is equal to 32, we are going to break the loop. And n basically represents the amount of teams in this list here, or the amount of links or website pages in this list here. So you can see this is what our list looks like. We have every team and every year from 2010 to 2020. It's a pretty long list. So now we could actually finally start to scrape the very first table that is very vital to this database or to this project, and that's going to be the team stats and rankings table. So it's going to be this table here, and we could get rid of these other tabs. So we set up a couple of variables. We create UZ equal to 0, I is equal to 0 as well, and then we have TSR underscore final as a empty data frame. While UZ is less than 352, what this means is that in this list here where we had the specific team and the specific year for them, in total for that list there are 352 rows. So that's why we have it set to less than 352 or 351. I don't remember exactly off the top of my head. And so with that, we can begin to scrape the table. So we have our link, and then we are going to say while I is less than 4, we are going to read this web page or whichever link or whichever position UZ is on. Read that link, read the web page, parse it, go through it again, and then we are going to scrape all of these attributes and their values. And I had a bit of help from Excel in setting this up because this section here is very repetitive, and I basically used Excel formulas to help shorten the process of creating the column names and searching for what we wanted to retrieve. So you can see we're looking at the player points, total yards, plays offense, yards per play, all of that good stuff on this table. And on their website, they name it as something else for the column names, but when you go to inspect, it's actually named something different. So that's one thing to keep in mind with this table. And so this is nothing we haven't seen before. Once that is done, we are going to create a staging data frame and then append it to the data frame on the outside. And one more thing I want to mention is that we need to try and figure out or differentiate which team and which year we're looking at. So on that specific page for the team in the given year, luckily for us, we are able to retrieve the team name and the year that we're looking at. So you can see after all of that, we are setting up a staging data frame, which we created here. And then we append it to the data frame on the outside. And we add 1 to I, and if I is equal to 4, we reset I back to 0. And then we add 1 to UZ, meaning that we're moving on to the next website link. And the reason that I is set to equal to 4, or if I is equal to 4, we reset I back to 0, is because in this first table, we only have 4 rows. So I know once we hit 4 rows, or once we get through 4 rows, that's it. And these 4 rows, or these rows and columns, are the same for every team and every year. They don't change. It's not like we're looking at a passing table where we could have maybe 2 quarterbacks or even 5 quarterbacks playing a given season. And you're going to see how we handle that later on in the coding. And this is just basically a print statement that I did for myself to check where the coding was at, because this takes a very long time to complete. And it's pretty long, but we can minimize this and we can move on to the conversions and team stats. Conversion team stats. So more of the same thing, just like the last table. It's going to consist of 4 rows static through all teams and years, and the columns, of course, is going to be different, but when we go to inspect it, we could easily retrieve our data values. So it's going to be the same thing here that we've seen in the previous table, and there's nothing really new to add here. It's just that we are now looking at team conversions. Excuse me, I actually skipped the table. So this is what the table looks like after we scrape everything and put it in a data frame and do whatever data manipulation we need to do. And there's one thing I messed up on, is that I put player, or the text of player is not supposed to be there. If you look more closely at the table, it's supposed to be team stats, opponent stats, league rank offense, and league rank defense. But that's fine in my case. We could easily fix this when we're creating our database or in the ETL process. But other than that, everything on this table is consistent and matches up with what is on that link website or that team website. And then of course we export it to a data frame. I won't go through and open all the data frames because it's going to take a while, and there's a lot of tables in this code in here, or a lot of data frames in this coding that got exported to a CSV file. And this is something new that we're doing, or that I'm doing, is I'm encoding it into CP1252, and the reason is because on other scripts that I was working on, I came into an issue where apostrophes weren't being exported correctly into a CSV file. So with a bit of research, I was able to figure out that to have those apostrophes in there, because some players, they have apostrophes in their names, this encoding method here, or this encoding value, fixes that error, and everything else from my knowledge looked the same. So as I was saying before, we are going to do the same thing with the conversion team stats. And again, nothing new that we're adding here. This is what the table looks like. So it's a lot smaller of a table with less columns, and probably should be the same amount of rows because we're working with 4 rows. And you can see our player mistake here. And that was a mistake that I missed because it's so many columns and rows that I have to look out for. This it's just that I missed it. But again, like I said, we could easily fix this in our next step. And you can see that we have the team name and the team year. So Washington football team, they were once named the Washington Redskins, but changed due to some issues in 2020 to the Washington football team. So 2019, 2018, and you can see we have all of the data there. And then you also see the Arizona Cardinals, excuse me. This gets exported to a data frame exported to a CSV file as well. Alright, so now we are going to look at a different table. We're going to look at the player stats now. Although they're still part of a team, we're looking at player stats more closely. So the first table we're looking at is the passing stats. So you can see this is what the table looks like on the Pro Football Reference page. In 2010, for the Arizona Cardinals, they had several quarterbacks play for them. They had Derek Anderson, John Skelton, Max Hall, Richard Bartell, and Steve Breston. In football, sometimes a player not assigned to the quarterback position can throw a pass, and so it's going to get recorded here under the passing stats. And one more thing I wanted to point out, and this is something on the Pro Football Reference website, and I don't know why they have it like that, is that for some guys and some players, I would say they don't have a position listed next to them. And it's going to be hard to figure out what position these guys play, but this is something we handle later on in another script where we scrape all of the players from this website. Because John Skelton, I know he plays quarterback, but I don't know too much about Max Hall, but I can assume that he plays quarterback as well because of his number and because of, just general football. I think I might have heard his name once or twice, but if you don't watch football like that, you wouldn't know that he plays at the quarterback position, because you have Steve Breston here. They listed him as a wide receiver, but if that wasn't there, then you could probably assume that Steve Breston, played quarterback, because his number is a typical quarterback number, and he didn't throw as many passes, but sometimes that happens in the NFL. Not every quarterback is going to get a ton of playing time. Also, I want to mention is that we're not dealing with static rows anymore. We are past the old age of just scraping 4 rows and that's it. Now we have to account for the amount of rows that are in this passing table or even in this rushing and receiving tables, because from year to year, players, they leave teams, they sign with new teams, or different amount of quarterbacks will play different games. So in the next year, 2011, there may only be 3 quarterbacks that play or attempted a pass for the Arizona Cardinals compared to the 5 that we have now in 2010. So we also have to account for that. And we could go back to the script here and see how we did that. So we set up our variables, of course. I is equal to 0, Q is equal to 1, TU is equal to 0, M is equal to 0 as well. And we create a new variable called uniform number, and that's going to be equal to the string of Q. And then finally, before we enter into the loop, we are going to create a data frame. So now, for team links in team years, and team links is the links for the specific team and the given year, for the specific team and the specific year. So we're starting from 0. So we're looking at the Arizona Cardinals first. Once we do that, of course, we're going to go through the regular steps of opening the web page, closing it, parsing it, and that's it. And I mentioned earlier that we introduced a new package called comment, and this is where it comes into play. So I'm going to find all the comments on this specific website. And I was saying earlier is that for some reason, Pro Football Reference, they have all of these data values for the player stats, player and team stats, I would have to say, hidden behind a comment. So although you can see that this is table data class right and the text is 27, for some reason when I go to write it into the script, it returns nothing. And I was looking and through some research, I seen that they put all of their data values behind a comment. And I said, okay, if I could figure out a way to scrape this, then we are going to be in business. So let's look at how we did that here. So I'm going to find, and this was pretty simple. It wasn't too hard. Just finding the comments at first. So we're going to find all of the comments, and thankfully and luckily for us is that there's only one comment for depending on what table you're looking at. So we're creating this variable called PSC, and this is going to retrieve all of that comment text we just seen. Once that is completed, we create a new variable called R, and then we are going to open up a HTML file. This HTML file is called player stats. And the good thing about excuse me while I open up the web page. The good thing about this is that we do not need a link, actual website link to open up something in Google Chrome. So you can see this is not an ordinary link, but because we named it as a HTML file, it's going to treat it as if it was a website. So all of that text that you've seen hidden behind a comment here is the same thing on this page. So we have the information we need. So we wrote all of that comment to this file here, named it .html, and that's how we get it into a more scrapable format. Once that is done, and you can see here we're right into the file, we have to change it to a string. Once that is done, I'm then going to read that file that we just created and saved, or that file that we just wrote to. And this is not going to be on the Arizona Cardinals, excuse me, because we're looking at the last team that the script or the loop performed those steps on, which is the Washington football team, of course, but it's all the same thing in the end. So now we're going to read that HTML file, and this one I had to do a bit of research because this is a new method for us on how to scrape from a file path, even though we have HTML at the end of it. So now we're going to find all, and the first thing we are going to take a look at is the passing table. And you can see we have everything here. We have the passing table, the rushing and receiving table, punt table, defensive table. So this is a lot more easier for us, or it made it manageable for us to actually get to this point of scraping the data. And then we are going to focus on the first table here. PSR is the first table. It's the passing table. And then we could look for our tag and our attribute values and then retrieve the text. So now, hopefully that made sense, and it is a little bit confusing, but it was innovative way I thought of, like scraping the comments from this web page. So now we can move on to another loop that we created. And as I was mentioning before, we are not dealing with static rows anymore like we seen with the player, opponent stats, league offense, league defense, the 4 rows that we were seeing earlier. Now we have to account for all of the players that attempted the pass and are recorded in the passing table or even in the rushing and receiving tables. So this is how we did it. So we said I is less than or equal to the length of the player underscore DV underscore 2 minus 1. Once we do that, we are then going to scrape all of the data values that we need. So we are going to look for the uniform number, the age, the position, the pass completed, the passes attempted, or the amount of passes completed, and the amount of passes attempted, excuse me. So we go through all that good stuff, and you can see that it's going to look the same as the table we have here. And the good thing about this is that visually looking at this web page or our file here is that it doesn't really matter what it looks like. The only thing that matters about it is, are we able to scrape the information, and can we put it into a data frame to later be used in a database that we will create? And the answer is yes. So like I said earlier, we are now at the point of scraping the individual data values, and then of course I can't forget to add the year for the player that through the amount of passes or all these stats are recorded in, and the team that they are playing for. So once we do that, we're going to retrieve the text from all of those previous variables and then put it into a staging data frame. And once we have all of those values, and the reason why we have try and except is because some stats may contain nothing. You see, like QB record may contain nothing, and if we don't account for that, or the position here contains nothing, and if we don't account for that, then we're just going to return an error for everything. So that's why we use try and except. So going back to what I was saying, we have all of our text or all of our data values in a staging data frame that we created here, and then we are going to append it to our data frame on the outside. And so after that, we are going to add 1 to I and 1 to Q as well. And if the length is equal to I, or in simpler terms, if I is equal to the amount of players we have here, then we can move on to the next link. You can see here that we add 1 to TU, add 1 to M, reset I back to 0, and Q equal to 1. And this will basically represent us moving on to the next link. And you can see I did a bit of a print statement just to print the player name, the year, and how many players were in that given year. So you can see John Skelton 1, 2, Max Hall was 2. And then we are also scraping the team total, but we're going to take care of that later on. And you can see there are a bunch of names that we have to go through. And one more thing that I want to mention, for some reason, Pro Football Reference, again, they had these weird symbols. I guess it denotes, I would have to say, if a player made a Pro Bowl or something, or some type of note that they put next to the player name, but I'm not too worried about that. So you see, we have all those players, and I'll minimize this again. So after that is said and done, and keep in mind that this takes several hours to complete. not just the passing table, but this whole script, because it's just so much data that we're looking at. We're looking at data from 2010 all the way up to 2020, and we have to go through it 10 times for 32 teams. So it's going to take some time. And we're not only looking at the passing table, we're looking at the rushing table, the kicking table, and the defensive table as well. So you can see this is what our table looks like. And it's going to be the exact same thing as our file here. So now we export that to a CSV file, of course. And we basically do the same thing for the rushing and receiving table, kicks and punts return table, kicking and punting table, defense and fumbles table, and that was it. That's the only tables I wanted to look at. And then you can also see I changed it up a little bit to show a percentage completion. And we are getting rid of the team stats or the team total and the opponent total here by just filtering out where the uniform number is equal to a empty string, and we then export it to a data frame. And I'll have to make an adjustment again to the passing stats to remove those rows as well, because they should not these two stats or these two rows should not be in there, because we should be able to easily calculate it in our database or when we're querying data. So again, going through the kicking table now, see it's being completed, and this is what the kicking table looks like. And then again, going to remove those rows and export it to a data frame, or export it to a CSV file, excuse me. We have punting and field goals. This is what the data frame looks like. It's going to look exactly the same thing as the CSV file. And also to mention, the reason why we filter out the empty string is because every player is required to wear a number. So if a player does not have a number, that most likely means, or that should 100% mean that this is not a player we're looking at, and we could go ahead and delete those rows. So now moving on to the defensive stats. Basically same thing as everything else. We have our defensive players, a whole bunch of columns as well, and all of these CSV files that are being saved are going to get exported. Are going to get imported into a database, excuse me. And that's the end of this script. So we looked at data from 2010 to 2020. But for this upcoming season, and I'm not sure if this script will work, but I have faith. And the reason why I'm not too sure, but I still have faith, is because the NFL season hasn't started yet. But this script right here is going to take a look at the current season, 2021. And I can't run this script now because there's nothing there. The 2021 season hasn't started at the time of me recording this video. But based on what we've seen so far, we can assume that this format should remain the same. You see, we're looking at this website or this team page right now, and we're missing the passing tables, the kicking tables, the defensive tables. So we can't run this script yet, or we're just going to return errors. And I export all of the, and it's the same thing, but the files are renamed something different. Like you can see, it's named current team stats. As the if you look at the other file, it's probably going to be named NFL team stats. But other than that, that's pretty much it for these two scripts here. And we can move on to the next data set.